Thanks, y'all. I'm going to talk to you a little bit about my research that I've been working on for the past year and a half, looking at Helene damage, specifically Helene wind damage on our forest canopies in western North Carolina. So hopefully I can lead you on a little journey, answer some of the questions that we might have, and tell you a little bit about also some of the work that the Natural Heritage Program is doing in response to Helene and what I'm going to be doing for the next several years. Wow, that's a really touchy. I see why people have problems today. So right after the storm, this phrase I feel like was thrown out a lot. I feel like a lot of blank came down. And some of those fill in the blanks that I heard some of y'all saying were things like white pine, scarlet oak, red oak, and then on the flip side, there were things like, oh, I feel like tulip poplars, tulip tree, they didn't really get damaged all that much, all their leaves just came off. So in other research in this region after hurricanes, we have actually found a species correlation with some species are being more prone to wind damage and tree fall, some of that being scarlet oak and black oak. So what I wanted to know and find out was if there's actually any truth behind that statement, figuring out if species was indeed a predictor of tree fall. So I came at this question kind of with two different approaches, the first being spatial analysis, kind of at the landscape level, and then the second being field-based analysis. So I'm really glad that we've already kind of gotten an introduction to some of the work of Steve Norman and their HiForm project, because that was a big basis for one, my spatial analysis, and then just plot selection in general. So this map here is looking at the forest damage from Hurricane Helene, specifically to our forest canopies. Okay, you can see the red, that's good, that's the most important part. So this is that mapping done, again, by the U.S. Forest Service, their HiForm project, in the several days following Hurricane Helene. So this imagery was taken in early October, where pixels in red indicate your large gap blowdowns. So those are the areas that with the catastrophic, huge acreages of just trees coming down one after the other, like toothpicks. The orange, yellow pixels are your severe or mixed damage. The blue is scattered low severity, and then everything else is no impacts. So looking at this, I wanted to know if there was an ecozone or a forest type that suffered more damage than others to try and start and hone in onto the species question. So the other part of my spatial analysis to help answer this was using Steve Simone's work, our ecozone layers, where I took his ecozones, 20 for the Southern Blue Ridge, and I took out the treeless areas, so like grassy balls, things like that, and then combined the other categories to reduce it to 8, being spruce fir, northern hardwood, cove forest, high elevation red oak, montane oak hickory, dry oak, low elevation pine, and pine oak heath. And our fire adapted communities are indicated with the little flame icons. So with these two kind of spatial layers, what I did was I just combined them together. And for any of the other GIS nerds out there, I used it using the tabulate area geoprocessing tool in ARC, and then following it with a multinomial logistic regression to basically see if there was actually any sort of significant differences in between the impacts to these forest types, rather than just looking at proportion. And what I found from that, the other thing I wanted to mention before that, so in this type of regression, in this type of analysis, you do need a baseline, so something that you compare everything else to. And I used cove forest as our baseline because they're the most ubiquitous across the landscape in Simone's data sets. So these results are in relation to the cove forest. So for example, northern hardwood forests overall were significantly more likely to have extreme forest damage of all of those categories, all 3 categories, in comparison to our cove forest baseline. High elevation red oak forests were also more prone to damage. Montane oak hickory forests had slightly elevated odds. Our lower odds were our low elevation pine forest communities, where they had significantly less damage than our cove forest baseline. Pine oak heath had somewhat less odds, and then spruce fir and dried oak forests had about the same odds of damage in comparison to cove forests. So looking into that, knowing that there's maybe some community patterns, if our high elevation communities were most impacted by wind, does that also translate to the species level? So are we going to find species that occur within northern hardwood communities more impacted than others across the landscape of western North Carolina? So that brought me to step 2, was my field analysis, where I went out to a bunch of different plots across 2 counties. I had study areas and field plots occurring across 2 damage severity classes. So again, that large gap blowdowns, the things in red, and then no impacts within those 8 ecozones that I talked about a couple slides ago. So the reason why I decided to only do 2 of the damage types rather than all 4 was time. The master's program is not a PhD where I can spend like 7 years working on this. I had 1 field season. So I had plots at Roan High Preserve up in Mitchell County, and then at Headwaters State Forest in Transylvania County, which is just right up there. And in each plot, I took data both at the plot level, but then at the tree level as well. One of the most important things that I took note of for each tree was its damage classification. So I took note of whether or not the tree was damaged, and it had either a slight lean, major lean, slight crown damage, major crown damage, trunk snapped, or was a tip up / wind throw. And here in the center picture is a photo of the major crown damage, which is just 50% or more of the crown of the tree was totally damaged. And then trunk snapped is just, again, that trunk is snapped, but the roots are remaining in the ground. And so from that, I looked at the patterns of damage across species, and this is a little bit chaotic, so I want to describe it before you get overwhelmed. On the y-axis, you have proportion, so it's just the proportion of each species and how the type of damage it incurred. And then on the x-axis, you have the species. So there are 2 things that I wanted to note about this in particular. The first being that there were 4 species groups with absolutely no tip-ups or wind thrown individuals found across any of my plots. Black gum being one of them, pines, and pines I had to group as a genus into 1 species group because there just wasn't quite enough. Black locust, and then basswood. The second thing that I wanted to note that I thought was interesting was that there were 3 species that experienced over 50% of their individuals had damage of some kind. And so that was Fraser fir, Fraser magnolia, and black cherry. So whether or not this tells us anything, if any of these trees were more prone to tree fall, I did have to turn my data into a binary data set because I was working with way too many variables that my model was very unhappy, and I had to essentially combine some of the worst damage, quote unquote, into tree fall. So major lean, major crown damage, trunk snapped, and tip up became tree fall, and then everything else became intact. And with that, I ran my analysis again to find this. Again, busy graph, I'll walk you through it. Species group on the y-axis. On the x is your species deviation and tree fall probability, that log odds. And what I want you to pay attention to is the 0, the dashed line. So if the species data crosses that 0, that means it didn't differ significantly from the average rate of tree fall. So anything that crosses that line fell as predicted or just as much as any other species. So there are 2 species that I want to draw your attention to. Super interesting. Fraser magnolia and sourwood. So those are the only 2 species that I found across all of my data plots that were more prone to tree fall when it comes to comparing species to species. I was expecting scarlet oak, black oak, like other folks have found in this region following hurricanes. So I was like, okay, that completely goes against everything that I have read about and was expecting. So what else is going on in these plots? Is there anything else that might be driving a predictor of tree fall? Right, exactly, I just said that. So what was going on? And that brings me to my why trees fall model. Here it is in all its glory, in plain language. It's just the probability of tree fall as a function of the tree size, estimated total rainfall, wind exposure, and estimated maximum wind gusts while controlling for species group and plot. So from each of these variables, there were really only 2 that I found that were significant, that could be drivers of tree fall. And that was DBH, tree size, and wind exposure. So I found that larger trees were more prone to tree fall. And this here is just a visual that I put together to show that, where I created a DBH index that essentially shows within species this pattern was also the same. So smaller trees within a species were less likely to come down, where larger trees within that same species were more likely to come down. Again, on the y-axis you have your proportion, and then on the x is that index value, with values less than 1 indicating species that were smaller, and values that are over than 1 or species that are larger. So you can see a little bit of that trend here, where the larger trees are more prone to coming down. By far, the absolute most significant thing for predicting whether or not a tree came down was just if it was on an exposed site or not. So here I show fallen trees and their corresponding aspects. On the y-axis is the proportion, and on the x is the aspect. And this is just looking at the fallen trees themselves. So out of all of them, the most trees occurred on southeast and southern facing aspects, and none on the northwest or north facing aspects, and very few on southwest and west. And this makes a lot of sense because Helene came from the southeast, and so those slopes that were facing south and southeast got the brunt of some of our winds. There are a couple of limitations from my study that I do want to talk about, because I think it just adds to the picture of what's going on, and I think you're going to hear today and tomorrow and on Thursday too some folks talking about their work and what they found, and some things are different across the landscape. So the first thing I want to mention was just the limited availability of storm weather data. I was really surprised to find that things like rainfall and localized wind gusts weren't a significant predictor of tree fall. That may be true, but it also might not be true. Because of the fact that Helene was so intense, a lot of our weather stations failed, either the day before or the morning of. Like 3 a.m., pretty much every single wind station in western North Carolina just went out. So finding accurate enough data and localized data, that's one thing here in the mountains where we know like mountain winds occur all the time, that some of these like coves or certain sites could be experiencing specific winds and downbursts that might have a lot to do with when and how trees came down. The other thing I wanted to note was just the reliability of the forest damage spatial layer. So a couple of things are going on with this work and this high form like spatial analysis. The way that it's put together is that it looks at vegetation greenness, like Jean was talking about, and so it picks up any change in greenness within that time window. And so usually you look at seasonal windows, so year to year. So this data set uses October 2023 compared to October 2024, the week after Helene. In Headwaters State Forest in particular, a couple of my plots that were supposedly quote unquote high severity damage from Helene were actually just TSI, timber stand improvement, like mid-story reduction treatments that succeeded, so great job whoever did that, but it meant that there wasn't actually any blowdown in those areas. So with that was a limitation in the study. I think in the spatial analysis as well, I think some of the northern hardwood areas might have just seen more leaf stripping. That was a big thing with those like super heavy winds, and particularly just in early October, which already coincides with leaf off here in the mountains. So that's a limitation in this study in particular that I'm really excited to continue working on and looking at as we get more imagery, more spatial data to just like really dig into that and see what it looks like across the landscape. And then lastly, I don't know if any of y'all picked up on this, but pines having almost no damage whatsoever. I know that that is not the case because of the fact, especially in Headwaters, a lot of my plots had pines that were totally on the ground just outside my plots. So I couldn't actually measure them. So it didn't show up in my data set, and that could just be due to the sampling design not having quite enough replicates to capture what's fully happening across the landscape. But it could also be, there could be some truth to that. So to answer the big question, at this scale, species was not really a predictor of tree fall. Wind exposure and tree size were. So Fraser, Magnolia, and Sourwood, as we saw, they were more prone to tree fall. That could be due to sampling design and other things, but trees on exposed sites and larger trees were more prone to tree fall. And just overall, more research equals more answers. And this might change based off of the scale that you're looking at. Again, I was looking at that landscape scale, where I know some folks here in this room are looking at more forest and stand-based analyses, and they might find something different than I found. Lastly, I want to talk a little bit outside of trees, if there are wind impacts to other things, particularly looking at rare plants in the understory. So one of the first things that I noticed and Natural Heritage Program folks noticed following the storm was that these hurricane-induced high light environments are really good for some species in the short term. So for example, this is 2 separate sites. These are glades in western North Carolina. Really lovely, but both of them were in the middle of high severity blowdown. And so we were really curious how the glades fared themselves. So far they're looking okay. And in one instance in particular, the echinacea with the thumbs up picture, that population actually expanded because of the increased light. So we love that. We love that a lot. On the other side though, the other friends / enemies that are loving the light, but we don't like it that they're loving the light, are our non-native invasive species. In particular, I didn't take any data on this, but there were several plots that I had of this extreme canopy blowdown where it was essentially like walking through a carpet of Tree of Heaven. It was not fun. It was very stinky, and I think that's going to be something that we're going to be dealing with for the next several years. So there are some plants that are loving it, and we love that for them. There are some plants that are loving it, and we don't like that. On the other hand, there are other rare plants and things that we're concerned about and have questions about, and we don't know how they're doing with Helene impacts. So this plant on the right with the question mark is glade spurge. It's a really lovely northern hardwood species. This was found in, again, one of those high blowdown, high intensity plots of mine. Again, this was at the end of the season, so the sun burning could be due to just the late season, but we also just don't know how it's going to respond here long term. We don't know that about a lot of our plants and other things. So the last thing I'm really excited to share is that the Heritage Program recently entered into a Good Neighbor agreement with the Forest Service, where it's a 10-year agreement, and it essentially quadrupled the staff in the western region of the Heritage Program, and we can focus on Hurricane Helene recovery and monitoring both on national forest lands and then some neighboring lands. So I'm really excited to be working on that and trying to maybe answer some of these questions about, okay, what are the Helene impacts to some of our natural communities, some of our rare plants, some of our rare aquatic species, and things like that. And then that brings me to the end, so I'd love to take questions. I do want to shout out just a big thanks to the Southern Appalachians Highlands Conservancy, Headwater State Forest, and the U.S. Forest Service for letting me traipse around these really extreme blowdown areas and to collect my data. So thank you. Yeah, Armin. Yeah, that's a good question. And I didn't look into the granular level of whether or not that pattern for sourwood existed, whether or not larger sourwoods came down more so than smaller ones. I think what happened is sourwood is an intermediate canopy species, and so it just got smushed underneath bigger trees that came down more often. And those bigger trees could be anything, ranging from your oaks, from magnolia, whatever. But because it was just underneath everything, it just came down along with it. Yeah. Yeah.
Thinking of host dynamics, successional dynamics from this point forward, based on everything that we saw, the trees that were remaining standing and minorly injured or not, do you get a sense of how healthy they were, or are we likely to see more mortality even though they didn't die immediately?
That's a really good question. John asked about delayed mortality and things like that. So I conducted my field research within a year of the storm, so I think probably too soon to see some of those impacts and effects. There were some areas where trees remained standing that got pretty beat up by other things coming down, and I think those guys not do great in the long term. But some areas, particularly in like northern hardwood communities, where the trees that remain standing were things like buckeye, and they didn't get beat up on the way down, but they're looking okay. Yeah, Jordan.
Two things. One, real sorry for the messy signal there in our state forest. I'll take responsibility for that for TSI Jones.
I mean, it looked great.
Second, to your point about the that signal from other management or activities, we saw that on the Grand Wagner Ranger District and Wilson Creek Permit as well, with what looked like a huge, like multi tens of acres that blowed out. Was actually a really severe burn on a real tiny site in the burn unit. Just happened to be that one section of it, and so that's something that we found is really interesting too. Is like, the model's really good at picking up the signals, but because of the time frame in which you're looking at that window, it may pick up on other things too. So I just want to reiterate that point. Notice that in a lot of other places as well.
Yeah, and to add to that, I didn't add it to my slides, but I did redo kind of their analysis using summer imagery. So comparing summer pre-Helene, summer post-Helene to see how it differed. It differed a lot, but again, last summer was so wet and so green that it probably also picked up on new growth within the canopy gaps. So I've talked to Steve about this, and we're really excited for some of the LiDAR imagery to come out, because that'll allow for some really accurate spatial analysis. Great, any other questions? Yeah, Harmon.
One more thing, I'm glad you mentioned all the herbaceous species that have come up. I'm curious if those sites where you saw those herbaceous species come up, did those sites have much herbaceous species beforehand? Or is this a result only of Helene now being all this light? And what's the importance of bringing fire to those sites?
Yeah, so Armin was asking about like herbaceous regrowth in some of the sites, and if we knew about what was there before and after, and some of the fire management implications. I think one of the most difficult things with dealing with natural disturbances and studying them is the lack of pre-data. So I didn't have pre-data for any of my plots, so I can't answer that question. But post-Helene, yes, a lot of herbaceous growth, some really amazing herbaceous growth, like over my head, snake root that I've never seen before. Yeah, when it comes to fire management in some of the areas, I'm sure some of the areas that are in those fire adapted systems would love it, and it would help to push it more into kind of what we're looking for now that like the light is here and like the trees are already down. As for other areas, I'm not sure. I'm excited to see what we all find out.
Thanks,
Well, thank you.